Alrighty, hello everyone. Thank you so much for tuning in to our workshop on getting started with Python and Oracle database. I am so excited to introduce our next speaker of Global Hack Week. We have Veronica, who is a project manager over at Oracle, or a product manager rather. So I am going to give it over to you, Veronica. You can take it away. I will see you soon.
Hello, I'm Veronica. I'm a product manager at Oracle. Thank you, Mary, for having me today in this session. Okay, so let's get started with using Python and Oracle database. First, I will just give you a quick overview of the python-oracledb API. So on the right-hand side, the python-oracledb driver sits in the middle, and it's loaded by Python. It gives an API that you can call. It connects to the Oracle database for all standard relational and JSON operations, including SODA, that I'm not going to speak about probably today. So what you need to know is that to make our developers and users' lives easier, in May 2022, we released a new renamed version of CX Oracle, namely python-oracledb. This is a major upgrade of CX Oracle 8.3, and the python-oracledb driver enables direct access to Oracle database through its thin mode. One way to think about the upgrade is that we added a thin mode to CX Oracle and made this mode the default. So the database can be on the same machine as Python or remote, allowing connections from platforms that don't have Oracle client libraries installed. It's an easier deployment and a smaller installation footprint, so you can get a better use of resources and better performance. Now, because of thin not needing the client libraries, this lets you play with it on platforms such as Apple, Silicon, and IoT devices. The driver is still a binary module, which is needed for performance, and now Python OracleDB has Mac OS binaries, and they run on Intel and M1 and M2 chips. Of course, you still have an optional tick mode that does use those Oracle client libraries, making it the same as CX Oracle. So that gives you actually a runtime choice to use tick mode. And we know that users want all available functionality to be in the thin mode, so you don't need Oracle client libraries at all, but that's an ongoing project for our team. It provides support for Python 3, namely 3.8 to 3.13, and then we continue to support Python's database API v2 specs in both thin and thick modes. This means that it works with frameworks and ORMs such as SQL Alchemy, Django, and Pandas. And of course, the driver is still open source using GitHub for its repository, and the license just got updated to Dual, Apache 2, and UPL. Just a few words on installation. It's very quick and simple to install. The name has changed to OracleDB. In terms of size, the total size is about 20 megabytes on a Mac OS for a fully functional driver, immediately usable in applications, including dependencies. So you can optionally install instant client libraries to be able to use that tick mode that I mentioned earlier, as traditionally used by CX Oracle, and the basic package adds about 240 megabytes on macOS. So thin mode has a definite size advantage. Just a note, if you are using the tick mode, you must always call init Oracle client to use this tick mode in any platform. So just a few points here. If you are on Mac OS or Windows and you have installed Oracle Instant Client libraries because your database is on a remote machine, then set this Instant Client dir to the path of the Instant Client libraries. If you are on Windows and have a local database installed, then comment out the two Windows lines, so then the Instant Client dir remains none. And in all other cases, including Linux with Oracle Instant Client, make sure that Instant Client dir is set to none. In these cases, you must make sure that the Oracle libraries from Instant Client or your Oracle Home are in your system library search path before you start Python. On Linux, the path can be configured with ldconfig or with the ld library path environment variable. Okay, just a few words about what we are using today. We use Live Labs as a platform to run this hands-on lab. Live Labs is particularly helpful when learning new technologies, allowing you to practice and apply the concepts that you have learned. without the risk of damaging your own compute or DB instances. I'm going to walk you through the tutorial, which is named Getting Started with Python and Oracle Database. The tutorial provides Python sample files that you could actually use or reuse as needed. So you can also get URLs to those sample files in the lab. The tutorial is an introduction to using Python with Oracle Database, and it contains beginner and advanced material to explore the features of the python-oracledb driver for Oracle Database. And after configuring your environment, the sections or the labs can be done in any order. You choose the content that interests you and your skill level. Today, I'm just going to walk you through some of these labs. The material which is publicly available is actually a 2 hours material. I'm probably not going to be able to run through all of that. So I'll just like pick and choose stuff which I consider that it might be of interest for you. I'd like to point out that there are specific labs for running Python OracleDB driver only in tick mode. And these are labs 9 and 10, and then labs 2 to 8 and 11 can run in both thin and tick modes. Okay, so just a quick overview. What you need to run through the live lab is you have to have access to a laptop, and then you need to have an Oracle account. If you don't have an Oracle account yet, in the next slide, I'm providing you the steps you need to perform in order to create an Oracle account. So you need to access this URL. Which is giving you an Oracle account for free. If you need any help setting up the account, we have some people in the chat room, so please give a shout and they will help you to get set up. If you have an Oracle account, then use that account to sign in, then you are ready to start the hand-on lab. Okay, so let's do it. What I'm going to show you now, I'm just going to open up a browser and navigate to the link above and then sign in with my Oracle account. And then in the page that opens, I'm going to show you what you need to do. Okay, so let's do it. This is the page that you will see. I will sign in. Okay, I'm signed in. And then here you see this button called Start. If you click on this, you have the option to say, run it in your own tenancy if you already have an OCI environment, or you can say run on Live Labs Sandbox. That means that you will use one of our tenancies in OCI, in the cloud, in Oracle Cloud. So when you do that, you will be prompted to consent to receiving emails from Live Labs, and then you can submit a reservation. Once you submit a reservation, now I'm not going to do that right now because I already have a reservation in place. And a point that I wanted to make is that when you have a reservation, until that reservation expires, you will not be able to create another one. So to access your reservations, you just click on your Oracle account on the top right corner, and then My Reservations. And let's launch the workshop. Okay, so once you launch the workshop, you will get all the instructions, namely the labs that you have to run through. And I mentioned to you that there are some labs which are about the configuration, the environment setup, and then the rest of the labs can run into any order. Now, also, if you want to view your login info, we give you access to the tenancy on OCI. There is a username, and then there is a tenancy, and there is a password for that user. Also, there are some URLs which you might find interesting. I'm going to launch the OCI. And here I'm in the cloud. And I have on the left-hand side menu options to, for example, I could create a compute instance, like I can create Oracle databases. Now, for the sake of this lab, what we did is like we automated the creation of the Oracle database. So when I click on autonomous transaction processing, and then I go in the compartment, which is specific to my user, my login user, so that's user 110598 in this case, I will see the database which has been created. So this is automatically created in the live sandbox for you. Now, when I click on this URL over here, I get to see general information about my database. And I'm going to walk you through seeing the database connection. So in my database connection, I can see my connection strings, which are used when I connect to the database from Python. And also there is an option to connect to the database using a wallet for security reasons. I'm going to use this in the live labs. So let's go through the live labs actually, and then let's just like go step by step through what we need to do. So okay, I mentioned that the database is already created. So the workshops here only start with the environment setup. I have a schema in that Oracle database, which is called Python demo. And then Python demo has a bunch of tables created, and also data has been populated in these tables. I'm just going to show you how this looks like. I'm clicking database actions, SQL. And then here are all the users in this database. And I'm just going to go to Python demo. And then I have a bunch of tables. I can do select star from Python demo dot departments. And I run this query. And I see the data in the departments table. You notice that when I log in here, I logged in as admin, but I have the option to log out and log in with the Python demo user. If you are creating your own database, then you set the credentials for the users. And then there are some scripts which are provided. I'm going to walk you through that in a second to create all the tables in the database and to populate the data in the respective tables. Also, you have the options to use the config for generating passwords and config years for the admin user. Okay, so let's get started. I mentioned the driver. This is already installed in the OCI as well. And I'm going to use something which is called Cloud Shell. So let's get back in here. So Cloud Shell is a web browser-based terminal accessible from the Oracle Cloud Console and available to all Oracle Cloud infrastructure users. It's free to use within monthly tenancy limits, and it provides access to a Linux shell with a pre-authenticated CLI and other useful tools for following Oracle Cloud infrastructure service tutorials and labs. So let's access that. I'll just select here Cloud Shell. And also you saw I have something which is called code editor. And this is a rich in-console editing environment that enables you to edit code and update service workflows and scripts without having to switch between the console and your local development environment. Let's do code editor. So I have nothing over here. This is my home directory. And if I go back to the instructions, the first thing that I have to do is I have to get my database wallet, which is later on used in my scripts, my Python scripts to connect to the database. So let's do that. Going back in my database connection, download wallet. I have to give it a password. Okay, so that's been saved. And with that wallet, I'm just going to come and upload it on my Cloud Shell. Okay, so I have my zip archive. Now what I'm gonna do is, so I went through the steps of downloading the wallet, uploading the wallet to the Cloud Shell. And now I have to download this automation shell script, which is really just a bunch of instructions that I'm using to populate some environment variables, initialize some environment variables, and unzip some files and move things around. So let's get that and run it again in my Cloud Shell. Okay. I have tutorial script.sh. So now we want to run it. You can read through what this is doing, really. So it's creating a wallet directory, it's installing Python Oracle module, and then it's downloading the sample files that are used throughout the workshop, and then it's just configuring the environment setup and then letting me know that it completed. So now when I do an ls minus LTR, I will see here the wallets.
Hey, Veronica, we had a couple of requests in chat to zoom in your screen, if that's possible.
Okay.
That is all. Sorry for interrupting.
How do I, sorry, I need to know, how do I'll try to.
It should let you zoom in if you do Command plus.
Oh, zooming on the Cloud Shell?
Mm-hmm.
Okay. Let me, what I'm trying to do actually here is like, let's see. I'm trying to switch on my Firefox here. Okay. Okay. Okay, so let's see. You see this folder called samples? So if I do cd samples, tutorial, I have a bunch of py scripts, which we already make available via the public URL for the live lab. And these scripts are used throughout the labs that we are using. So feel free to just download all this and then modify the scripts as you need, alter them, adapt them, using them by your own need. And then also there is this SQL folder over here. So if I do cd SQL, you will see that I have all the scripts which are used to set up the tutorial, to create the schema in the database, to drop the schema in the database, and then there is a bit of a dbconfig and drcp query. Okay, let me go back. Also, I was mentioning code editor. Now I already have all these files loaded over here, but I wanted to show you what code editor is doing. So you can just like go file, open, and then you can specify which directory do you want to open. In my case, because I have all my scripts under SQL tutorial, I'm just selecting tutorial over there. So I open this here, then I see everything on the right, on the left-hand side, all my scripts on the left-hand side. And also I have the option, if I want to run the script over here, I can launch a terminal. So I can just run Python 3, okay. and the name of the script over here. I'm not going to use the terminal. For some reason, I don't like doing that because here I want to keep this clean, just like to be able to review the code and make the changes in the code. By the way, this is saving. Autosave is enabled automatically. So any changes that you make over here, they will be reflected. So for the sake of practicality, what I do is like I keep the Cloud Shell on the left-hand side and I keep my code editor on the right-hand side and I just run all the scripts in here. Okay, so let's go back to the, I'm going to switch between these two. Now I have two instances, I'm sorry. I'm going to switch between the instructions. It's easier for me actually to Alt-Tab. So let's see what we've done. So we launched we ran the tutorial script and then we got the samples file being downloaded. We got the environment variables being set up. And now what we can do, so I don't have to install Python because this comes already installed when you launch that sandbox. But you can check what version of Python is being installed, and you can also check what version of the python-oracledb driver is being installed. To do that, let's first of all check that it's there. Okay. It's there, version 2.4.1. You can also do Python 3 help modules, and then you can see all the modules that are installed. I'm not going to run that. I leave that for you. And I was mentioning code editor. This is how you open up the folder. This is the sample files tutorial, all the scripts that I showed you in there. And now, what we want to do is like we want to test that one of those scripts is actually working. And before I show you how we actually connect to a database, and then in my example, I have a script which is really displaying the version of the database. Okay, it's a very simple script, but I want to walk you through what I need to do behind the scenes to enable that, because I need to set up my connection. So the connection to the Oracle database is using a few arguments. One of them is the user. In my case, I'm using the Python demo user that I created, the password, and that's obviously the password for the respective schema in the database. And I need this DSN. The DSN, let's see over here, is what I showed you in the database connection strings. Okay, so it's the TNS name. In my case, that. You can also use the connection string expanded, but best is to use the TNS name. Config directory is the location where the DSN connection string resides. And then I also have the wallet location. That's the folder that I created using the automation script. And then I have a wallet password. This is the password that I entered when I downloaded the wallet. So then you remember, because that password, the wallet password, is not necessarily the same password as your schema used for the Python demo exercise. Now, there is also this file called dbconfig.py, and let me open the dbconfig.py so then I can show you what that looks like. And what this is doing is really like getting all those environment variables in these variables: user, password, config dir, DSN, wallet location, and wallet password. Okay, and I'm gonna import dbconfig in all my other scripts. So the environment variables are already populated or initialized by my automation script. dbconfig.py and also dbconfig.tick, which is the counterpart of thin dbconfig, but running it in tick mode. So this is using the Oracle client libraries. It's also using the same environment variables and populating the same variables. The only difference is that I have this init Oracle client call that I mentioned in one of the slides, telling you like this is how you switch between thin and tick mode of the driver. So let's go back and really test the connection to the Oracle Autonomous Database. For that, I'm going to just run one of the scripts. So it's called connect.py. And if I run here a Python 3 connect.py. Okay, so I have a connection to the database because now I get a version of that database. It's a database 23.6. Let's actually open the connect.py and see how it looks like. So I'm importing the driver. I'm importing the dbconfig, the file where I initialize all these variables that I'm using in my connection. And now I create, so oracledb.connect, this is a method, which is the method used to connect to an Oracle database. And I'm creating this con, which is an object, which is going to preserve that connection. And what I'm doing over here is like using the object con, I'm just calling the method version. It's very neat, very simple. You can use this like for testing most of the time if your connection to the database is working. Are there any questions here? If you have any questions, because I feel like this is a paramount information. If we are clear with how we connect to the database and how we use the Oracle driver from a Python script, then I think that we can just move forward. Nancy, please let me know, or Mary, please let me know. Okay.
We've had a couple questions come in the chat, but the Oracle team has been answering them.
Okay, that's great. So then we can actually move on to the next live lab. So I'm just going to talk briefly about connection pools. Connection pooling is important for performance when multi-threaded applications frequently connect and disconnect from the database. There are actually two types of connections to the database. There is like the standalone connection, the one that I just showed you in the previous script that I ran. But also, so that's a direct connection to the database, but pooling gives you the best support for Oracle's high availability features. So what you do is like you use a pool if you have a lot of connections that will be used for short periods of time, or you have a small number of connections that are idle for long periods of time. And the pool advantages being that it reduces the cost of setting up and tearing down connections, or even dealing with that connection detection. And once acquired from a pool, a connection behaves the same as if it was created as a standalone connection. So you can use external authentication to avoid hard coding of credentials, and then with clause ensures that the connection is closed once the block has completed. This can be closed explicitly with connection closed, and it will be closed automatically when connection gets out of scope. So that's pretty much the summary of this. I can just go into the first task now. So there is a script called connect pool py, and sorry, give me 1 second. What this is doing is let's stop connect pool. Let me restore this. Oh, not here. Okay, so what this is doing is using pool, an object which will use this method called create pool. This is what you use in order to use connection pools. And then I'm also importing a package which is called threading, and this is a module for creating and managing threads. Now, you notice that I have more parameters now when I use create pool as opposed to creating a connection to the database. Now I have this min equals 2, max equals 5, increment equals 1, and then there is also this get mode OracleDB pool get mode wait, alongside with the user password, DSN, config dir, and wallet location and password. What are these actually? Say, for example, min is the minimum number of connections that the pool will maintain. So even if there is low demand, two connections will be kept open. Max is defining the maximum number of connections the pool will allow. So the pool can open up to 5 connections in this case, but no more than that. And increment indicates the number of additional connections to open when all connections are in use and more are requested. So since increment equals 1, it means that only one connection will be created beyond the initial pool size. Sometimes you actually want to, there are practices where you say like you specify the min and max connections to be equal, and then you have the increment equals 0. And that means that no additional connections will be created beyond the initial pool size. That means that, let's say the min and max were 20, then pool is always maintaining exactly 20 connections with no allowance for dynamic scaling based on demand. Let's walk through how we do this in the script. So I have a method called query over here, which is called by each thread. And pool acquires a connection from the pool. If no connection is available, it will wait. So this is because I have here get pool get mode wait. Threading dot thread over here creates two separate threads. So thread 1 and thread 2, each of which will run the query function concurrently. Now, let's run. I also wanted to tell you about join. So join ensures that the main program waits for both thread 1 and thread 2 to finish when finish executing before continuing. And where you see here thread 1 start and thread 2 start, this starts both threads, which will run the query function concurrently. So how it works is that both threads, number 1 and number 2, acquire connections from the connection pool and run the query function, fetching sequence values 4 times each, because I have the pool handles the connection in a way that ensures that there are always between 2 and 5 connections available, because I have a min and max specified in the create pool call, and then the threads wait for a connection if all available connections are busy, thanks to the pool get mode wait option. Now let's run this. So this is my 4 threads. Sorry, my 2 threads executed 4 times because of this. All right, let's move to the next lab. Next lab is called data fetching. And what it is about, it's executing select queries to get data from Oracle database. And then there are a number of functions you can use to query an Oracle database, but querying is always the same. So you use it for parsing the statement for execution, for binding data values, for executing the statement, and for fetching the results from the database. Let's see how we do that. By the way, if you run this in your own pace, like you will see here for each of these tutorials or labs, you will get like a short video, which is going to walk you through the steps that you need to perform. So if you get stuck at any stage, you can just play the video and then you will see what you need to do. Okay, so the first example is we are going to use a simple query. So I have a script which is called query2.py. This is how it looks like. It's going to create a connection to the Oracle database using the credentials as before. And I'm going to create a cursor, okay? And then I'm going to keep that in this object called CUR. And the next thing that I'm going to do is like I'm going to call the method execute. So when I call execute, I can just like specify the query that I want to be run in the database. So this is my query. I'm selecting star from departments order by department number. I showed you this query just before. I don't have the order by, but this is pretty much what this is doing. So I'm supposed to see all these lines being retrieved. Then, because I have a cursor, every single row is going to be kept in this object. And for each of those rows, I can print the department number, department name, and department location. Okay. Now let's go and just see how this works. So let's copy that. Department number 10, accounting in New York. Department number 20, research Dallas. So all 4 lines are being displayed. I can also show you how this looks like. So query 2. Okay. It's pretty much whatever is in the tutorial. The next task is to fetch using fetch1. So I have another script which is called query1py. And again, I'm using the connection object to connect to the database and creating a cursor again, selecting from running the cursor, cursor execute to select from departments. And then I want to display 1 row at a time. So what fetch1 is doing is just like retrieving only 1 row in a sequence. So what I'm doing is like I'm fetching that row in this object called row, and then I'm going to print it out, and then I'm just going to move to the next one. Again, I'm only going to get 1 row, and then I'm going to print it out. So let's go ahead and run the query. So I get my first row. Let's get to query 1. And then if I want to display the second row, I will uncomment those and run the script again. And now I have 2 rows being retrieved. All right. Next task, fetching data using fetch many. So fetch1 was used to just retrieve 1 row from the database, from the cursor. And I have another script which is called query many. And query many, as you would guess, is going to fetch more than 1 row. And you have the option actually to specify how many rows you want to retrieve. In my case, I'm using this variable called num rows. And then when I call the method fetch many, I'm just specifying I want to retrieve 3 rows. So let's copy this and run query many. You notice I have now 3 rows being retrieved. If you want to have a look at, let's do query many. If you want to look at the first row only, you have the option to specify res 0. And also, if you are looking at just displaying the second element of the first row, you can specify res 01. So that's like the element in the list. Let's run it again. So I'm printing res, and then I'm printing the res 0 and res 01. All right. Now, tuning with array size and prefetch rows. In this tutorial, in this task, I'm mentioning that we have a table which is called Big Tab, which has been created as part of the setup when we created the schema and populated with data. This is a very large table. It has 20,000 rows, and I can show you how this looks like quickly. So really like a column with strings, like 20,000 rows, okay, large table. Why is this important? It's important because when I do array size, I want to be able to control how many rows do I want I want to prefetch and I want the cursor to have. So every time, say for example, like in a array size of 100, I'm only retrieving 100 rows. And then each of these is going to require a trip to the database, to the server. Why is this important? This is important for performance. Array size attribute determines how many rows the cursor will attempt to retrieve in a single fetch operation. And by adjusting this value, you can optimize performance when retrieving large result sets. Increasing the array size can reduce the number of round trips to the database, like I mentioned, when fetching large amounts of data. And then setting array size too high, though, may lead to increased memory usage. So it's important to balance the number of rows fetched with available system resources. As a default behavior, you can always reset array size to its default value if you find that a specific value does not work well with your use case. Okay, so let's have a look at this query array size PY. What I'm doing here is I'm just going to show you. So I'm using this package called time. And then what I'm doing is like I'm going to show you how long it takes for this script to retrieve all those 20,000 rows from the big table if I have a array size of 100. And then what you can do when you run through this exercise on your own, you can actually play with these numbers. Just a good, let's say, like practice is to set the prefetch rows to be just like one number higher than the array size, because when you have this when they are equal over here, the the application doesn't know if there are any more rows to be fetched, and it's going to go and do another trip to the database. So if you want to save that one extra trip, I would say use here a prefetch rows value of 101 and then array size leave it like 100. Of course, this is in the case that you have a table with a large number of values. If you have a table with a small number of values, then you don't have to adjust these parameters. Let's go ahead and run this script. Let's see how long it takes to retrieve all those 20,000 rows. And I'm going to show you meanwhile how it looks like. This is a script. Okay, it took 23 seconds. Now check what's happening when I change this to be, for example, 2000. Let's set this to 2002. One second. If I set this one to be 20,001, .7. So just feel free to play with the array size and prefetch rows methods. Okay, let's move on to the next chapter, which is binding data. Probably you already know what are bind variables. They enable you to re-execute statements with new data values without the overhead of reparsing the statement. And why is this important? Because it's improving the code reusability, application scalability, and then reduces the risk of SQL injection attacks, which is why we strongly recommend using bind variables. We have a script called bind query py, where I'm using, again, the object con to connect to the database. Then I create a cursor. And I'm using prepare method to say, hey, run this select where my filter is going to be on department number, but you see this is a variable, and then again I'm ordering by department number. Now, when I execute the statement, I'm specifying that I want that to be run with ID of the department being 20. So this value is going to be passed to that bind variable. And similarly, I'm using the fetch all because I want to fetch all the records from all the rows from the database. And then I'm just going to display the results. After that, I'm just going to use the department number to be 10. I'm going to fetch all the rows, and then I'm going to print the results. So let's go ahead and run this script. I made a change, I think, over here. So let's check what I did. I wanted to show you this as well. So when I'm passing an ID, which doesn't exist in the database, then I'm just going to get this type of result. It's like an empty row. If I am uncommenting those lines and I'm passing the ID 300, I'm passing, oh, sorry, so it's 20 here. I'm passing the ID 20 and 10, and I rerun the script. Then I get my rows corresponding to those IDs. Okay, there is also this statement cache size. Statement caching is allowing the database driver to cache SQL statements that have been previously executed, and caching actually improves performance by avoiding the need to recompile SQL statements that are executed multiple times. So when a statement is cached, the driver can reuse the cached version instead of sending the same SQL text to the database every time it needs to be executed. So in this case, const statement cache size is an attribute that manages the size of the statement cache for a database connection, and the statement cache size is configurable for each connection. That's why over here, it's telling me that it's caching for 20. That's the size of the cache. Okay, let's move to the next task. Binding in inserts. Similarly to running queries in the database, we can use bind variables when we run inserts. So notice here in this script, we have, again, a connection to the Oracle database, and then we create this cursor because we try to run a statement which will insert many values in the database. So I have an object called rows, which is a list looking like this. So I have an ID and then a description for that. And then I have a list of like 7 elements. And I'm trying to insert those values into a table called my tab, where I have 2 columns, ID and data. And then the values are specified as bind variables, and then when I run the statement, the bind variables will just be replaced with each of these values. Okay, so I don't have to run the same insert into table 7 times. I'm just using execute many, and then the bind variables will just like fetch those results. So after I do this, I will query the results back, and then I'm using the another cursor on the same connection. And with this one, I'm just querying the data from my tab. So I'm going to display all the lines. So eventually I have to see this. Let's go ahead and run this script. Bind insert. I wanted to show you what I did here. I created a duplicate line. I went ahead one step. Because I wanted to show you that if there is a duplicate ID, then the database is just gonna throw an error telling me like there is a violation of the unique constraint. And it's not gonna insert that row, but it's gonna insert all the other rows. Why is it doing so? It's doing so because I have this param over here in the execute menu, which is telling me that batch errors is true. When batch errors is true, that means that all the valid records get inserted and the erroring ones are left out. Now, also what I can do in this script is like at the end of the script, I can say, I want to commit the transactions or I want to roll them back. So if I get an error like in here, I might say, hey, then roll back all the other transactions. But maybe when I'm reviewing the results, I'm saying like, hey, that is a valid error and I don't mind it, which means just go ahead and commit the rest of the transactions because what is being inserted is correct. Okay, we still have like 8 minutes and then I will try to speed up and then see what else I want to show you. Let's go to PL SQL. This lab, sorry, let's get my cursor back on the screen. This lab is using another table which has been already created and populated for you. It's called ptab, and then there are some PL SQL stored functions and procedures that were created. So in this case, I'm talking about the my function. This is just like showing you how you can create a function in PL SQL. What this function is doing is like it's taking these parameters, dp in and ip in as well, and then it's returning a number. And how is that number returned is really like is doubling the value of IP. Okay, and also during this function, I'm inserting into ptab my data and my ID columns the values DP and IP, which are the params of this function. So again, we have a PUI file, which is creating a connection to the database and is using again a cursor. And this is just an example of an object res, which is initialized with the result. It's retrieving the result of calling that function because the function is returning a number. I'm telling like, okay, call func is running for my function that I created above, and this is the return type of the result, and then these are the values that I'm trying to insert in the database. Okay, and this is the ID that eventually is going to be doubled by the function. So let's go ahead and run this script. And because my ID was 2 in that example, let's go and open up PL SQL func. So my ID was 2, then the result is going to be 4. Okay. There is also something which is called PL SQL procedures. Similarly, this procedure is using ptab, and it declares a variable called myvar, which, let's scroll to the, let's put this on the screen. Okay, so it declares a, what the procedure is doing is taking one numeric input, the v1p parameter, and calculates its double again, assigning the result to the output parameter v2p. Now, when I use the PL SQL proc.py script, you will see that I declare this variable myvar that will be used to hold an output value returned from the store procedure. And this core var method allows you to define a variable that can be passed to or returned from the database. So in this case, it's being defined as an integer. And the core call proc, I call it like with my proc, the name of the variable of the procedure, and with the parameters that I invoke it with. The input is the 1, 2, 3, and the output is my var. Now, when I do print the results, I do myvar.getValue, and this method retrieves the value from the bind variable myvar. Just go ahead and run it. And that's the number because my I passed 1, 2, 3, so the double of 1, 2, 3 is 2, 4, 6. I can show you this over here as well. This is the script. So the procedure, you will not see the procedure. The procedure is actually stored in the database. So if I would go back to the database and search for the procedure and the function, you will just see the definition over there. Okay, we still have 3 more minutes, and I wanted to use this time to maybe ask if there are any other questions. There are also other live labs, like I showed you, that we can go through. One which I think is important is follow the lab called tick mode. This will just give you an overview of what you need to set up to run all this in tick mode. Why is tick mode important, first of all? Tick mode is important because not all the functionality which is available in tick is also available in tick, in tin. And just examples here: advanced queuing, scrollable cursors, soda. They can only run in tick mode. So if you want to just go ahead and follow through one of these labs, I would suggest look at the scrollable cursors. And this is showing you that, first of all, you have to use the dbconfig tick as dbconfig. So don't use the file which is only initializing the variables. Do the init call to enable tick mode as well. All right, that concludes my session today. If there are any questions, please go ahead and ask them in the chat. Thank you very much for attending.
Amazing. Thank you so much for presenting today, Veronica. I know we had a couple of folks just asking about the recap for this. You'll be able to catch the full recording of it on our YouTube right away. But I think
Yes.
all of the questions got answered by the Oracle team. Looks like it. But lots of thank yous in chat coming through. Awesome. Well, Veronica, I will let you go. Thank you again so much for taking the time to present today. For everyone in the chat, like I said, you'll be able to catch the recording right away over on YouTube. We have another workshop starting in 2 minutes on here. So we will see you all soon.
Thank you, everyone.
Bye, everyone.
Have a good day.